Okay, yesterday we studied about fossil fuels, okay? Can you remind me, Mohammed, what are fossil fuels? Mohammed. Okay, he's out. Sophie, Selma. Good morning, Selma.
They are the animals and the plants that died and were deep buried,
And
like
they
the sand
form.
piled up above them, and they
Okay.
became and they used stored energy in them.
Yes, thank you. So here in fossil fuel, we said the power station that use fossil fuels, the fuel is burned to turn the water into steam, and then the steam will run the turbine, which is like a huge fan. Okay, these turbines will run the generator to generate electricity to deliver it to the houses and our homes and factories. We said also that burning fossil fuels can produce carbon dioxide and other fuels which could pollute the air and change the climate. Coal, oil, and gas are the remains of plants and animals that lived millions of years ago, and we also explained how they formed from trees and sea creatures. Today we will study about generating electricity. So what does it mean when we say generating electricity? Generating electricity means producing a voltage so that a current can flow. So when we produce it by generating this electricity, we are producing voltage. When the voltage is produced, the current will flow through the wires, and then in this case, we said generating electricity. So what's happening inside the generator? So we all know that there is a link between the electricity and the magnetism. So what is that link between electricity and magnetism? When we have, let me get the pencil. When we have a coil, okay, and we have a piece of magnet, if we moved this piece of magnet in this direction and that direction, we will have magnetic field. This magnetic field can make the wire, can create a voltage. So when the current flows in a wire to produce, just a second. Good morning, Matasan. Matasan, can you get the mic, please? Okay, so here we need this movement to create this current. So when the current flows in a wire, it produces a magnetic field around it. Even if we move this magnet, we can produce a current, okay? And we will come to this later. So this is the link between the electricity and magnetism. With the electricity, we can work the magnet, like the electromagnets. We use electricity to work out, to make the magnet work. Okay. Now we will have a simple investigation to work out this one. Yes, Matasa? Sarah, good morning. So what is our simple investigation? We have a coil of wire which connected to a voltmeter, and we have a bar magnet. We will start to move this away and forward, like forward and backward, and we should see what is the reading for the voltmeter. So if we have the voltmeter on 0 here, okay, and we connected this voltmeter with a coil of wire, and we have a bar magnet in our hand, okay? So if we move this forward towards the coil, we will get positive reading, which is the arrow will move in that direction on the right, positive, okay, above 0. And if we hold the magnet still here on the top, for example, or kept it inside the coil, we will get 0, no reading. But if we moved it away from the coil in that direction on the left, the reading will be in that direction, which is with the negative reading of the voltage. So what's happening exactly there? What's happening exactly? Let me share the
The coil is the magnet right now, or what?
now here, as you can see in this picture, if she's moving the magnet, bar magnet into the right direction, she will get a positive reading here, okay? You can see my arrow? Okay, let me use the pencil. She's getting with a positive, okay, above 0. If she hold it still, she got 0. But if she moved it to the next to the other direction, which is for backwards,
It will go to the negative side.
Internet very bad, that's why. Okay, it's okay. It's okay, Matasan. At least you can see and hear what we are saying, right? Okay, so if she moved this away from the magnet, or away from the coil, she got minus reading, okay, with the other direction, to the other direction. So what do we conclude from this? What do we conclude, or what's happening exactly there? Can you think about it?
The electricity works with the magnet or something? Like, what brought that to generating electricity? I didn't get it.
We will come to the generator.
The magnetic field creates an electricity.
Yeah, just a second, Sophie. Now we are explaining what's happening inside the generator. This is a simple investigation, small investigation, or simple investigation that show you how the generator works inside. So now we will start, this is, you can say, preliminary work, okay, to explain more about the generator. So now we are working with the low voltage, okay, which is using a bar magnet and small wire, okay, coil. Yes, Sophie, you said what?
The magnetic field generates the electricity.
Yeah, a voltage has been produced, okay? We created or we produced voltage when we moved the magnet forward and backward. So this is the coil, okay? So if we move the magnet there and here, okay, we will create a voltage. This voltage has been produced, and we can say induced, like it's like created in the coil of the wire. Okay, that's what happened exactly. Okay, so if we replaced the voltmeter by a lamp or other circuit component, what do you think might happen?
Like if we put bulb, the bulb would light up.
Yeah, that's good. If we added a bulb, the bulb will light up because the current will flow to the circuit. So this is the wire, and we have here a bulb. Don't forget the symbols, okay? The light will be on if we move the magnet. It's like the voltmeter reading, okay? If we hold the magnet still here, can we get anything? Can we get a light or something?
No.
No, because we don't have any voltage running through the current. Yes, Matasan? Okay, thank you. No. So we don't have anything if we didn't move the magnet. If we moved it, we will create voltage. We will produce a voltage or induce a voltage in the coil, so it will just go through the circuit. So the current will flow through the circuit. Okay. if we repeated the experiment again, but this time by holding the magnet still. Okay, so now I have the magnet here. Okay, and through the, around the magnet, I have the coil. And we have here the voltmeter reading, okay? The voltmeter. So if I start to move the coil itself here and there, left and right, okay? What do you think the result that I will get? Am I getting a reading or not?
From left to right?
Yeah, if I move the wire, okay? If I move the wire, the coil, not the magnet, am I getting any reading?
Yes, no. Like
Yes
if
or
we are
no?
moving it, like if we are moving it to the magnet, I guess yes, right?
I'm moving it, okay? Mu'tasim, you said
Uh,
what?
no, I don't think so because there's like you're moving the coil,
I
right? You're
see.
not like
Okay, Mu'tasim said yes. Okay, Sophie,
I I say no.
you said no. Sophie, Muhammad Idris,
Yeah.
Sarah.
What's the question?
I said
What's the question?
if I'm moving the coil, not the wire now. Sorry. If I'm moving the coil, not the wire, should I get any reading? What the result that I will get? Muhammad Idris, Sarah.
I don't think there will be voltage.
Okay, Sarah, Muhammad Idris.
I think it's a no.
Sarah said no.
Yeah, no, true.
Muhammad, I'm not sure, but I think yes. Okay, the answer is yes. Why? Because to be able to produce or induce a voltage, you need a movement, okay? You need a movement. So if you move the wire, if you move the coil, or if you moved the magnet, in both cases, you are moving. You are moving. So this movement will induce or produce a voltage in the wire. So the current will flow and you will get reading. So if you move the wire in the right side, you will get positive. Left side, you will get negative reading. If you hold it still, you will get 0 here. Is it clear?
Yes.
I have a simple example about this, which is the windmill. We all know the windmill, right?
Yeah.
The wind turbines, the wind turbines, okay? The wind turbines, they are depending on what? On the wind to be able to move. This movement will induce a voltage. So this is the idea, the movement, okay? When the wind start to move the fans, okay, the big fans, they will start to move, and in this case, they will generate electricity. Why? Because this movement induced a voltage, and this voltage runs through the wires. So this is a simple about the movement. So to be able to induce any voltage, you need a movement, okay? So now how can we induce a bigger voltage? How can we induce a bigger voltage? We need to move the magnet, okay? If we have this magnet, the same one, okay? The same one, with, for example, let me draw it bigger, okay? If we have, this is the, for example, the voltmeter, okay? Let's say this is the voltmeter. Have here the coil, the wire, and we have here the coil. If we moved it like, just like forward and backward, we will get this reading with positive, okay? And here with positive, with negative. And here we have 0. But how can we induce more voltage by more movement, by movement faster? If we moved it faster, in this case, we will get more reading and more reading in that side, okay? Or we can use coil with an iron core, okay? With an iron core, like has an iron inside it, okay? So this iron is more, it can conduct more electricity, so it will be good. Or we can use more turns of the coil. Here, we can make them more loops. Okay, we can make it more loops. Or we can use a stronger magnet. Okay, we have a small magnet. We can use a bigger one, which is strong, like we can use a stronger one. And we can test this by the magnetism, okay, the force of magnetism. So these are 4 ways that we can use
Miss?
to get more reading or bigger voltage. Yes.
The magnet force, does it depend on its like mass too?
Sometimes not. Okay.
But
Depending
mostly it does.
Hmm?
But most of the time it does. Like it does depend on the mass sometimes.
Selma, I cannot hear you well. You're moving or something.
I said the magnetic force.
Yeah.
Does it depend on its mass, like, or not?
Some scientists said like we can experience the magnet with its force, not with its mass. Okay, but I think more domains will, like, that means like more regions, okay, inside the magnet will increase the force of the magnetism. So we have more like domains, they will attract more and repel more, okay? So if we use the stronger magnet, in this case, we will have more voltage, okay? So now let's talk about the simple generators, okay? You can make, good morning, Naeem. We can build a simple generator. So in the simplest example of a generator in a bicycle is the dynamo. We call it the dynamo, okay? So we all heard about this dynamo. So what is this dynamo? This dynamo depends on the motion of the bicycle, okay, to transfer the energy of this movement to create electricity or voltage to light up the lamp on a bicycle. So if the cyclist is not cycling, the lamp will be off. If the cyclist is cycling, the lamp will be on. So this is the same thing that happened in the wire here, and that we have the wire. So we said, if we have a lamp, the lamp will light up, right? So this is the same thing. If he starts to cycle, he will induce or produce this voltage. This voltage will go to the lamp and make it light, okay? So this is the simplest generator, example of generator. Okay, what about the power station generators? What about the power station generators? How do they work and what they are using exactly to generate all this powerful electricity? Inside them, inside the power station, the generators there are very, very big, not the small ones that we are using in our houses. No, even not the ones that for the buildings, big buildings. No, they are much, much bigger, okay? So here they use moving electromagnets instead of permanent magnets. So if they use the electromagnets, we all know that the electromagnets are much stronger than the bar magnet, which is the permanent magnets, okay? They work with the electricity. So here, these electromagnets, they are much stronger. So what they should give us? They should give us more energy, more voltage, sorry, okay? So because electromagnets can produce much stronger magnetic field than a permanent magnet, so in this case, they will induce voltage much higher or much bigger. So the simplest generators, they are using weaker magnets, okay? But here in the power stations, they are using electromagnets. These electromagnets will induce more voltage because they can, they have much stronger magnetic, they can produce, they have, sorry, much stronger magnetic field. So in this case, they will produce or induce more voltage. So is it clear for you?
Yes.
Yes.
Okay, so this was all about generating electricity. It's not that hard. It's very simple lesson. How can you generate electricity? So first, we said generating electricity means producing voltage. Means producing voltage. Yes, Matasam? Sorry, a second. Mohammed, is it? Yeah, okay. So at first we said generating electricity means producing voltage, okay, that that leads to current to flow. Inside the generator, there is a link, as we know, there is a link between electricity and magnetism. So inside the generator, they work with the movement of the magnets, okay, or movement of the wire or the coil. So if we moved it towards the coil, we will have positive reading. If we hold it still, we will have zero reading. And if we moved it away from the magnet, away from the coil, we will get negative reading. So if we placed voltmeter, if we replace the voltmeter with the lamp or any other component with the buzzer or anything or motor, they will start to, the current will flow through them and they will start lighting up, making noise, okay, or move. The simplest generator, oh, sorry, we can increase the voltage by using these 4 ways, using moving the magnet faster or stronger magnet like the electromagnets. We can use more turns in the coil or coil with the iron core. So the simplest generator, we said, this is the example, like the bicycle dynamo. So if the cyclists start to cycle, they will turn the light on. If they stop cycling, they will turn the lights off. This helps them to cycle in the dark. And in power stations, we said the generators that there are so much bigger than any generator that we are using. Okay, and they are using electromagnets because electromagnets can produce, can have a stronger magnetic field or produce much stronger magnetic field around them. So in this case, they will produce high voltage that we need to run the homes and factories and all over the town, okay? So next lesson, inshallah, tomorrow we will study about renewable energy, which is solar and geothermal energy, and how can we generate electricity using these methods, okay? I need you to solve the yellow box, please. And as I said, don't forget to work on the revision question, okay? Any question about this?
No.
Okay, thank you, Mata-san.
No,
Sarah
thank you.
also. Okay, so see you next time, okay?
Okay, have a good day.